Good morning, everyone, and thank you for taking time. Great to see so much interest. I think this show doesn't need any more booth. We just expand the conference theater because there's so much interested. And thanks for taking time this morning to look into options for engineered plastics. When you look around here, there was a lot of activity for the right reason into food packaging, recycling, polyolefins, PET. But as Trinseo is here as an exhibitor for the first time, we thought, well, let's expand the scope a little bit and show you what else can be done with the polymers we make, and in particular, polycarbonate, PMMA, ABS, and polystyrene. So the first question that you might ask, Trinseo, who? You're right, because it's the first time we've been an exhibitor at this show. Well, we are a specialty material solution provider. We all love this corporate communications nonsense. What does that mean? It either tells you everything or not a glimpse more. We make polymers. And we do that with around about 3,000 employees globally. We make these polymers on 3 main continents and do that both for the polymerization process and also the compounding. Now you could question, hang on, a polymer producer, what do you do on a recycling trade show? The answer is partially already on that slide. You can see we've started to engage into recycling, and we've built up 3 first recycling facilities. A glimpse into the history of Trinseo. We've been independent from Dow 14 years ago and started engaging more and more in sustainability. In particular, some highlights on the left. We started to incorporate a mechanical recycled polycarbonate in our flame retardant range. 10 years ago, we launched a recycled PC ABS for automotive application, and there is an example at our booth. 4 years ago, we look into chemical recycling of PMMA, and that is, let's say, the legacy. Then in the bar in the middle, you can see we've acquired first recyclers. We built first dissolution technology. Dissolution, what's that? We've heard the term in Tom's presentation before, and I'll speak a bit about it. We also cooperate with Indaver on a specific stream and built a first PMMA depolymerization plant. Now, the first question that you can ask yourself, where do we fit? And as you can see into the overview, we fit into this other thermoplastics area, 10%, together with the polyesters, the polyamides, the high-performing polymers. So the first question you can ask yourself is there a future for this tiny, tiny fraction of polymers? Because I think it's clear to everyone, making a collection scheme feasible is a challenging task to do. However, we believe that these polymers are worth collecting, and we believe there is a future business case with the recycling technologies that we are developing. Let's have a look at that. I'm still puzzled that nowadays people talk either about mechanical recycling or chemical recycling, and then plot out the different conflicts they have. But this is the playground of thermoplastics recycling in the future. And I hope you can spot there's much, much more to do than just pyrolysis oil and shredding and repelletizing. Of course, it is clear when you start on the top left, end of life, and start sorting, if that infrastructure exists, you would like to keep the loop as small as possible. So for clean streams, mechanical recycling obviously is always preferred. And I don't have to add more here, because mechanical recycling, there are so many companies out there well established into that stream for various polymers. We also have solutions here, but you won't jump out of your seat over that. We also mechanically recycle the polymers we make, but there's nothing fancy new on that respect here. But then the next term is dissolution. What's that? You apply a solvent and purify the polymer. Ladies and gentlemen, operating with a solvent is nothing new for the chemical industry. So it's not something, if you think about glues, it's maybe nasty chemistry. No, it's not. It's a valid route for circularity, and we believe in a circular economy that has a vital role to play. There are, besides Trinseo, other companies involved in this solution. I'm aware of PureCycle and polypropylene, APK on polyethylene polyamide, PS Loop on polystyrene, but also Trinseo. And in particular, we focus on dissolution into polystyrene, ABS, and polycarbonate. Yeah? Both mechanical and dissolution, if you look where that arrow starts from, are mechanical recycling technologies. So we do not touch the polymer backbone, but recover the polymer in its entirety. Different from depolymerization, which is a route you can see we are pursuing for polystyrene and PMMA, where the chemistry allows you to unzip the polymer into its monomeric building blocks. To the best of my knowledge, that is possible for polyamide 6, PET, PLA, polystyrene, and PMMA. Yeah? So if the message today is there is more than just pyrolysis oil as a recycling route, then it was worth for me spending hours in preparing this slide. First recycling facility we are active is Heathland, a company located in Utrecht in the Netherlands, with a focus on polycarbonate and PMMA, which obviously has a nice fit into what we do: conventional mechanical recycling, repurposing, cleaning, washing, and then repelletizing it. And then let's jump into the different polymer streams beyond mechanical recycling of Heathland, and let's have a look into polystyrene. Now, polystyrene, as you all know, is used in various applications, including fridges, insulation and building and construction, but the holy grail remains in achieving food contact into dairy packaging. The first approach to do that, obviously, is through the mass balance approach. There is bio-based feedstocks available through the conventional routes. And we've made both bio-based and chemical recycling available, which is essentially the same product performance with an ICC certificate, you could say. The second one is a cooperation we started with a company called Indaver in Belgium. Indaver announced to build a first depolymerization plant for polystyrene. Trinseo is one of the off-takers of that output, which we can use into polystyrene, but also into ABS, sun, or latex and binder. The second option to achieve food contact for polystyrene is through an ABA structure. So you build a safety sandwich around it. In particular, the polystyrene needs to have a 20 micron top layer to make sure that no migration happens into the packaged good. And that is an interesting approach because polystyrene's properties are inherently a functional barrier. So you can apply that. And through 2022/1616 regulation, that is now possible to be used in food contact application as of October last year. This is a busy slide, but I'll walk you through it from left to right. From left, you can see we have a mechanically recycled polystyrene grade, which is 75% based on post-consumer collecting through what we call super clean mechanical recycling. I am the show, not the slides. You should follow me. But here you go. Take your picture. Be my guest. Made it? Okay. That's quick. Then we have the solvent-based purification with general-purpose polystyrene, already with a food contact submitted for direct contact, so not with an ABA structure. And of course, the depolymerization with the chemical recycled stream, which we anticipate has the same specification as commodity-traded styrene monomer. And last but not least, the bio-derived grades. Okay, that's on polystyrene. And next one is on polycarbonate. And what we've done here, we believe is an example of how the chemical industry is adopting to the circularity need and how we repurpose existing assets. What you see here is a long, let's say, long-standing legacy built up of knowledge around how to make and recolor mechanical recycled polycarbonate, where we've built a long-standing relationship in Asia Pacific. So the question is, how do we translate that into Europe? Well, we have a polymerization asset, and every box you see here in blue is from that existing process. Any box you see in yellow is new. So what we've did is we added a post-consumer stream, did an extra quality control, then we blended in with virgin polycarbonate flake. We developed a stabilization package, handed through a compounding step with an online melt rheology meter so that the quality control is consistent, and to homogenize it afterwards, we did a post-blending operation. All the existing polymerization asset to address the need in offering a circular material. And this is the outcome. You can see we have 50 to 80% post-consumer recycled incorporated into the polycarbonate Eco, caliber Eco range. 2 grades currently, and we can save up to 44 CO2 emissions, 44%. The downturns or the constraints, better, that mechanical recycling has, obviously when you look into the color shades on the left, you incorporate the color tint that it had from a previous life. So if you were to look into water bottles that were tinted in blue, yeah, these are transferred and conveyed over. But then the next thing to address that is dissolution. What's that? Dissolution is applying a solvent. That solvent only attacks polycarbonate, so you can easily filter out the rest. And then you have the polymer of interest in solution and can purify that through a cascade of filters. That's essentially the concept. So it starts with everything again in yellow. When we have access to end-of-life products, you apply the solvent. That's not new. Then you put the polycarbonate from a solid state into a viscous state. You can pump it through a cascade of filters. After that, you recover the solvent and you can use it again and again. What you see here is a picture from last year from our inauguration of the pilot facility. And in the picture in the middle, you see a typical polycarbonate building and construction waste. This sheet used to be transparent, crystal clear. Obviously, after 15, 20 years, lost its transparency, degraded, and turned yellow and opaque. When you add such a composition, which has maybe a coating layer or a tape or maybe aluminium end cap, into the dissolution process, the polycarbonate is removed and the leftovers is the PET tape and the coating. So in a way, through dissolution, you can purify your polymer much, much more than you can do with the conventional mechanical recycling technologies. Another example is this automotive headlight. The lens is a polycarbonate, and then it's coated to protect it against cracking. And you can see on the pictures from 1 to 4, from the middle to the right, that the purification takes up more and more impurities, and you come to a quality that is, we call it virgin-like. a light transmission of 85%, a haze below 2%. You can do a lot with such a quality in a second life. A spider chart over the overview of what we can do. Obviously, biomass balance is the way to go for regulated market. Think about medical applications. Mechanical recycling, always preferred. I think that's clear. If you look into CO2 savings per weight percent incorporated in your formulation. But it has its constraints, such as light transmissions, for instance, or flammability. Then we believe this solution is a nice intermediate step that can fit nicely between the mechanical recycling and the chemical or bio routes. Biopolycarbonate on the left has been made available with Caleb Echo 2 years ago. Last year we developed mechanical recycling, it's commercially available now. And the dissolution recycling is in pilot scale, and we're about to scale it up to a first commercial plant. A glimpse into ABS and Sun. We are looking into mechanical recycling. That's not so easy and straightforward because of the structure of ABS. You've seen the slide on polystyrene that obtains styrene. And of course, we can also apply that styrene to ABS, not only to polystyrene. Biomass balance is also available, and we've also are investigating this solution for ABS through a funded research project called Absoleo. Moving on onto PMMA. We are proud to announce we've built the first commercial demonstration plant on PMMA, similar to polystyrene, but not for ABS and polycarbonate. The chemistry of that polymer is so simple that you can unzip it. So with depolymerization, you can go back to the recycled MMA structure at a very pure or high purity, 99 and above %. That demonstration plant is now operating since 2 months in Rho, in the Milan area north of Italy, to add this route of recycling to the PMMA. So this is where it fits. At Trinseo, not only do we manufacture polymers, but also sheets made from PMMA, both through extrusion or through casting. Obviously, the molecular weight differs for both processes. In fact, if you cast a sheet, you can go into very high thicknesses. The molecular weight is in millions. You cannot remelt that. So what are the recycling options? Now there is, with this depolymerization, back into MMA monomer. Again, the preferred route is the smallest loop. So through our Heathland activities, if you can, do mechanical recycling, but complementary to that, we have now depolymerization on the right, and recycled MMA and PMMA is now available. Here is a glimpse into our portfolio. PMMA is used in various applications, ranging from automotive, lighting, and also building and construction. And you can see here, we incorporated both chemical recycling and mechanical recycling, ranging from 35 to 90%. Yeah? Don't want to go into the specific grades per se. If you have interest, our booth is just down this path, and I'm happy to host and have a more detailed conversation. Here again, just some pictures for illustration. We make PMMA both in cast and extrusion and for injection molding. And we've got already a first demo project with an artist for an important sports event in Paris later this year. And these are the 3 pictures on the right. So this is a little bit a glimpse, high level, for activities at Trinseo to look beyond mechanical recycling, find a nice gap between mechanical and chemical recycling. And this is how we look into polymers today. We believe that the polymers we make have a future in a circular economy. it's worth recycling and collecting them. We believe mechanical recycling and then dissolution and depolymerization come first. Keep the loop as small as possible. These recycling processes have a very high process yield, and that's needed to enter into the circular economy, we believe. Just as a scenario, if you were to recover 90%, so it means you have 10% contamination in your stream, and you do that 7 or 8 cycles, then you still retain only 50% of your formulation. Okay? I mean, a polycarbonate that goes into a building and construction might stand there for 15, 20 years. So essentially, we're talking about a lifespan of maybe 80 to 100 years. But that means these processes are needed with a high yield to come to a carbon neutrality. And only for the remaining bits, we believe these would have a fit, the biofeedstocks, as a complement, additional technology, not as the mainstream. So that was it from my end. I hope I gave you a little bit of flavor that there is more to recycle than just polyolefins and PET. And what we do in dissolution, depolymerization, feel free to reach out. Our booth is on the left, just down this path. And I'm happy to take any questions from the audience now. And thank you for your attention this morning.